So here's another example of a rational inequality. We're told that this big fraction on the right is greater than or equal to negative 3. And remember, there are some things that we can't do to solve rational inequalities. For example, you can't just multiply this whole fraction by the denominator to clear it and bring that denominator over here. That does not work. We have to use some other technique with rational inequalities. The reason it doesn't work is because that denominator might be positive, might be negative. Depending on the sign, is going to flip that inequality back and forth. So instead what we do, we have two options. We can graph it. If you want to graph this thing, that would be fine. You can go ahead and do that. But instead, since we haven't really gotten to graphing rationals yet, we're going to use a different technique. We're going to solve this algebraically. And to do that, we need to add 3 to each side. Okay, just to start off, we're going to get 0 on one side. Things get a lot easier when we do that. So here's what we have. 0 is less than or equal to 5. I'm going to change these to x's. It's going to be 5x minus 5 over x squared. And I think I can factor the bottom here. That might be helpful. That's going to be x minus 3 and x plus 1. Okay, and it's plus 3. So plus 3. Now that plus 3 is going to be 3 times x squared minus 2x minus 3. I'm going to leave the top unfactored and the bottom factored. This is not really an important thing. I think I might just save a little bit of time doing it this way. But if you factor both top and bottom when you multiply by the crazy one, that's fine. And now I need to combine all this stuff on the right into a single fraction. So to do that, we're going to say 0 is less than or equal to, and now we have a big fraction. Common denominator, right? X minus 3 and x plus 1. And the top of this fraction is 5x minus 5 plus 3x squared minus 6x minus 9. I'm distributing that multiplication from the right-hand fraction. And now we just combine some terms until this is a little simpler to deal with. There's no combining the 3x squared. That just is what it is. But minus 6x plus 5x, that's going to be minus x. Minus 9 minus 5 is minus 14. Okay, see this is getting better. And I need to factor this, which is not obvious to me how it needs to factor. So I'm going to use a big X. I'm going to say negative 14 times 3 is 30, 42. I think it's negative 42, I think. We'll see. And it adds up to negative 1. That's the linear term. So the numbers that I have to do here are negative 7 and positive 6. Now, when I factor this, it's going to be x minus 7 over 3, since 3 was the term in front of the x squared. And x plus 6 over 3. The x plus 6 over 3 simplifies. That's going to be x plus 2. But the one on the left does not simplify, so that's going to be 3x minus 7. However you do your factoring is fine if you can get yourself to this answer. There are a bunch of different techniques we've talked about in class. But the result is I get 3x minus 7 times x plus 2 on the top, and on the bottom I have x minus 3 and x plus 1. And that whole factored rational is greater than or equal to 0. Okay, now I'm ready for a sign array. So let's just build one right here. Pick this line. And you look at all the vertical asymptotes or intercepts. So let's do vertical asymptotes in blue. That's going to be x equals, I don't want to write here, the space is valuable. Our vertical asymptotes are going to be x equals 3, just put that here, and x equals negative 1, right there. And on the top, we have not vertical asymptotes. On the top, we have x-intercepts. Okay, this one is negative 2, and this one is 7/3. 7/3. 7 over 3. 7 over 3 is bigger. Let's see, here we go. If I knew fractions better, I wouldn't have messed up. 7/3 goes here, and blue 3 goes to the right of it. It is important to keep these in order. Otherwise, it gets a little confusing. So, there we go. We have x-intercepts, negative 2 and 7/3, vertical asymptotes, negative 1, positive 3, And now let's just make a list of our factors. I have x minus 3. I have x plus 1. And in magenta, which I'm already regretting because it clashes with my red, 3x minus 7 and x plus 2. Well, where are these things positive? X plus 2 is positive everywhere above negative 2. And 3x minus 7 is positive everywhere above its x-intercept at 7/3. Okay, now we go over to the vertical asymptotes. X plus 1 is positive everywhere above negative 1. X minus 3 is positive everywhere above 3. And now we just need to multiply down over these signs. So 4 negatives make a positive. 3 negatives make a negative. 2 negatives make a positive. 1 negative makes a negative. 4 positives make a positive. And now it's time to use this sign array to answer the question that was asked originally. Where is it greater than 0? Well, what are the positive numbers? I have positive numbers here. Okay. Everything from negative 2 to negative infinity. Where's another positive number? Oh, here's one. Between negative 1 and 7/3. That's positive. And there's one more positive at the end. Everything from 3 to infinity. Now you'll see I'm putting square brackets on everything. That's not correct. I just tend to write that way when I'm dealing with greater than or equals to, because I know 0 itself would be okay for some of these, not others. And the way you can tell the difference is because if it's an x-intercept, then it's okay. You can actually have a 0 for an x-intercept. But if it's a vertical asymptote, now you really can't deal with that, because a 0 on the bottom of a fraction means, well, it means trouble. Okay, so 3 gets a curvy parentheses, and likewise for negative 1, I think, since that was also from a vertical asymptote. So here is my solution to this problem.